Welcome to Maths with EJD. In this video, I'll be talking about primal-dual translations in linear programming. And to start that off, we'll be talking about transitioning between primal and dual problems, in linear, okay, let me just say in LP, right? In linear programming. Okay. Right. So, I already gave a hint on how this should be done in the previous video where you translate a maximization problem into a primal maximization problem into a dual minimization problem. So let's start that off by talking about the types, types of decision variables, types of decision variables. So just like I said in that video too, decision variables in the primal have implications on the constraints in the dual. So types of decision variables and their impact on dual formation, formulation. Okay. So that's what this is about now. Okay. On dual formulation. All right. So just like I said, right? Um, so in primal, you have dual, right? So decision variables here impact the constraints in the dual. Okay, decision variables in the primal impact constraints in the dual. Then constraints in the primal impact the decision variables in the dual. Okay, so we have that kind of thing happening there. Okay. All right, and that's exactly what we are going to see now. So types of decision variables and their impact on dual formation. Let's see how that goes. Um, the properties, the properties of the primal variables, influence influence the type of constraints. Decision variables leads to constraints. Influence the type of constraints they produce in the dual problem. Okay. Now imagine what kind of constraints can we have? Imagine number one, we can have restricted non-negative constraints. We can have restricted non-negative decision variables, right? We can have this kind of thing. So, that's when you have, okay, let's just even talk about that. So, if a primal variable, all the x1, x2 and all that, if a primal variable xi, maybe x1, x2 and all that is greater than or equal to 0, then corresponding, the corresponding corresponding dual constraint will be an inequality, will be an inequality. Okay. So what that means is, and being an inequality, that it can be in two ways. Number one, for maximization problems, for maximization problems, for maximization problems, the dual constraints, the dual constraints, the dual constraints, the dual constraint will be greater than, okay, or let me write it big, will be greater than or equal to 0, like the one we saw in the previous uh video. So if your primal is a maximization problem, and it has less than or equal to constraints, I mean, the variable rather is positive, sorry. The variable is positive, so that's going to lead to, um, so the dual constraint will be greater than or equal to zero. That means you're going to have greater than or equal to, greater than or equal to, not zero per se, right? Greater than or equal to, I mean, greater than or equal to. So if the first variable, say variable x1 is greater than or equal to zero, then it is going to lead to a greater than or equal to kind of constraint in the dual. We are going to give a practical example of this to drive the point home. Then again, for a maximization problem or for maximization for, okay, so that's for maximization problem. So then for minimization problems, problems, okay, for minimization problems, the dual constraint, the dual constraint, the dual constraint, uh, the dual constraint will be less than or equal to, less than or equal to, okay, less than or equal to, less than or equal to, right? So it means that if the first variable in the primal is greater than or equal to zero, then correspondingly for maximization problem, the constraint will be greater than or equal to zero. Then for minimization problem, it will be the first constraint will be less than or equal to zero. Um, in case that's not too clear now, don't worry. I'm going to make an example of that. So let's go for um, let's do so we can have restricted variables, right? Sometimes we can also have unrestricted variables. So like we now have unrestricted free variables, unrestricted or free variables, unrestricted or free variables. What that simply means is that the variable does not have to be positive. It can it can go in any direction. That's what unrestricted variables mean. So in this case now, I say if a primal variable, if a primal variable is unrestricted, if a primal variable is unrestricted, all right, meaning that unrestricted means the variable is a real number, so it can be negative or positive. That's what that means. So we say the corresponding dual constraint, corresponding dual constraint, okay, is an equality, because because unrestricted unrestricted primal variables, unrestricted primal variables imply imply dual constraints that are not limited, to a one directional constraint, to a one directional constraint. Okay. So that's variable leading to constraint now. Okay. That's what we have considered so far. Type of decision variables and their impact on dual formation. So we know that decision variables lead to constraints. Now let's see how constraints lead to decision variables. So again, let's talk about types of primal constraints, types of primal constraints, and and their impact and their impact on the dual Okay. So before it was types of decision variables. Now it's types of primal constraints like that. So here, each type of constraint, each type of constraint in the primal, each type of constraint in the primal problem dictates dictates the properties dictates the properties of the corresponding dual variables of the corresponding dual variables. Again, the idea is decision variables in primal dictates the kind of constraints you get in dual, and constraints in primal dictate the kind of variables, decision variables you get in the dual, basically. So you have that reverse kind of thing happening. So we have three situations here. Um, imagine that the first situation is such that you have less than, if you have a less than or if you have a less than or equal to constraints, less than or equal to constraints. So if you have a less than or equal to constraint, this is going to determine the kind of decision variable you are going to have, right? So we say that a primal, a primal constraint, a primal constraint in the form, a primal constraint in the form AI transpose X less than or equal to BI. So the key is this less than or equal to BI will correspond automatically. That corresponds to a non-negative, corresponds to a non-negative dual variable. To correspond to a non-negative dual variable, which is yi greater than or equal to 0. Okay? Yi greater than or equal to 0. So less than or equal to will correspond to a variable that is less than or equal to 0. That's the first situation. So imagine the second case. If you have a greater than or equal to constraint, greater than or equal to constraint, greater than or equal to constraint. Okay. So if a constraint is greater than or equal to, see what happens. So we say that a primal constraint in the form AI transpose X greater than or equal to B, where greater than or equal to is the focus now, that will result. So results in a non-positive. So it will result in a non-positive dual variable. To result in a non-positive dual variable. Non-positive simply means that yi now will be less than or equal to 0. So it will be 0 or negative. So non-positive means it doesn't go ahead above 0, basically. Okay. Then we can have the third situation where we have equality constraints. So if you have equality constraints, what happens? All right. So we say that a primal constraint in the form, a primal constraint in the form AI transpose X equals B. Equality is the key thing here. Equals BI produces, so that will definitely produce an unrestricted, so to produce an unrestricted, produces an unrestricted dual variable, an unrestricted dual variable, yi, which is a real number, meaning that it can either be positive or negative. So those are the situations we have. I think to make it clearer, right, it may be important to maybe do a kind of table, okay? Like put it into a kind of table. Um, okay. So let's say, let me just do Okay, let me just have for starters, right? If we have primal primal variable type, primal variable type, and then let's see the corresponding constraint, dual constraint type, something like this. Okay, so and then we have there are basically two variable types, right? So we can just have those two. So here now we have, imagine that we have restricted, restricted, that is non-negative, non-negative variable. That is simply talking about xi greater than or equal to 0. So, and we have two cases corresponding to that. So one case would be um for maximization, for maximization, okay, would automatically get a greater than or equal to constraint. Then for minimization, for minimization, the constraint type will be less than or equal to, basically. So if you check out the variable and you see that it is a positive, a non-negative variable, right? Then the dual, if the primal is, if the primal is a maximization problem, then the dual constraint is going to be greater than or equal to. Then if the primal is a minimization problem, then the dual constraint is going to be a less than or equal to. But yeah, I mean, most times you should expect a primal problem to actually be a maximization problem. So you can just stick with this one. Okay. All right. So that's when we have restricted or non-negative variable. Okay. So what if we now have um we have we have unrestricted, right? Unrestricted, unrestricted, or what you can call free variables, just like we saw before. Okay. So that means you have you have an xi, which is a real number. Real number means it is positive, it can either be positive or negative, right? It's just a real number. So in that case now, so the constraint, um, so I mean, what this means actually here is that this is a greater than or equal to constraint for maximization, and this is a less than or equal to constraint for minimization. Okay. So in this case now, if you have unrestricted free variable, then it means that you are going to have an equality constraint. You're going to have an equality, which is this constraint, equality constraint. By way of summary in a table, that's what we get. Then we can have another table for um for variables. Okay. All right. So again, imagine we have the primal constraint type, primal constraint type. Okay. And then let's look at the dual. You know, constraints will lead to variables. Eh? So what is the dual variable type each primal constraint type is going to give? What's the dual variable type it will give us? So here we have three scenarios. We have three scenarios. Okay. Now, for instance, you have if the constraint, you have a less than or equal to constraint. A less than or equal to constraint is going to give you a non-negative dual variable. So a less than or equal to constraint is going to give you a positive constraint. It's going to give you a positive dual variable type, right? So then another case is what if you have a greater than or equal to, so if the constraint is a greater than or equal to constraint, okay, that is simply going to lead to a less than or equal to variable. And lastly, if you have an equality constraint in the primal, an equality constraint in the primal is going to lead to unrestricted variable. So your yi here is going to be unrestricted, meaning it can either take positive or negative values. That's basically what this is about. Um, okay. So maybe to also make this one straight to the point, right? Instead of speaking, since I've spoken English before, let me just show the symbols. I think that drives the point home better, right? I think that should drive the point home better. Okay. So let me do it that way. Okay. So so I just minimize the English I'm speaking here. So here now we're saying that if you have a less than or equal to constraints, so less than or equal to constraint. Okay, no, the one at the top now. So it's variable. We're talking about variable here. So a if we have a greater than or equal to variable, okay, we have a greater than or equal to variable. No, okay, I think it's better to just do this. Yeah, okay, since you're dealing with variable. So if we have x1, xi to be greater than or equal to 0. So we have two situations for maximization. So let me just say max. For max now, we'll just have so it's variable to constraint, right? So here we have a greater than or equal to constraint, greater than or equal to constraint for a maximization problem. For a minimization problem, we'll have a I guess the space is too small, right? If the space is too small. So, uh, what if I just remove this and shift it down a little bit? Okay, something like this. So, for maximization problem, well, a greater than or equal to variable is going to give us a greater than or equal to constraint for maximization problem. And for a minimization problem, we are going to have a less than or equal to constraint. We're going to have a less than or equal to constraint. And then if the variable is free, like you have xi, if the variable is free, that is xi belongs to the real number, meaning it can be positive or negative, then we are simply just going to have an equality constraint. I think that summarizes it better. And finally, to drive the point home, let's just take an example, just one example. Take a primal problem, transform to dual, and we are good to go. So imagine this primal problem, okay, which is to maximize, want to maximize z equals c1x1 plus c2x2 subject to say a11x1 plus a12x2 less than or equal to b1. And then we have a21x1 plus a22x2 equal to b2. Pay attention. So you have a31x1 plus a32x2 now greater than or equal to b3. So you can see we have different types of constraints there already. And then this is also very important. You now have x1 to be greater than or equal to 0, and you have x2 to be free, like it's a free variable. Okay? It's not non-negative, it can take positive or negative value. So this is your primal now. So how do we get the corresponding dual? So let's go to the dual problem. Okay. Now, for the dual problem already, based on the laws we have, okay, of course, you already know if you introduce two new variables now, I mean, we're going to, because we have three constraints, okay? Okay, what do I do now? What do I do? Okay, before I even do the dual problem, let's look at it this way. Can we summarize what we have here? We have, um, we have two decision variables. We have two variables You have two variables and three constraints, okay? Two variables, three constraints. The two variables are x1 and x2. And the three constraints are, the first one is a less than or equal to constraint. The second one is an equality constraint. And the third one is a greater than or equal to constraint. I mean, this, and this. These are the three constraints we have. And the two variables are x1 and x2. So one is greater than or equal to 0, and the other one is just free. Okay. So now what it simply means is that when you get to the dual, when you go to the dual, have, you're basically going to have, so for two variables now, you're going to have two variables will result to two constraints. Okay. It will result to two constraints, and then uh three constraints will result to, so you see, let me do it this way. So I mean that these two variables are going to result to two variables are going to result to two constraints. They're going to result to two constraints. Okay. So because the variables are going to determine the type of constraints you have. And then constraints, these three constraints now are going to result to three variables. That's what I mean, right? Variables will lead to constraints, constraints will lead to variables. And the nature of each variable and constraint will determine the nature of the variables too. So that's really important. So variable to constraint, constraint to variables. So finally, let's go for the dual problem. Now that we know we are going to have two constraints and three variables. So we're going to have the dual problem. So what does the dual problem look like? So so we already know we're going to have three variables for the dual. So, okay, this is for the primal now. For primal, we have two variables, three constraints. So for the dual, we are going to have uh two constraints, three variables. This will be for the dual. Okay. So three variables automatically, it will come like this. It is going to match y1, y2, y3. So, and just like I said before, this is b1y1, b2y2, b3y3. That will be your objective function for the dual. So now you're going to minimize, okay, w equals, you're going to minimize w equals b1, y1 plus b2, y2 plus b3, y3. Okay, that is the objective function. Okay, with that taken care of, then we now go for the constraint subject to. So like I said already, the dual is going to have two constraints, okay, because we have two variables. Now the nature of each variable is going to determine the kind of constraint, right? So the first variable is a greater than or equal to constraint. What does the law tell us? So if you have a greater than or equal to constraint, it means that if you have a greater than or equal to, sorry, variable, sorry. If you have a greater than or equal to variable and the primal is a maximization problem, it means you are going to have a constraint that is greater than or equal to, okay? You're going to have a greater than or equal to constraint. So how does that work? Just like what we did in the previous case, right? So it means you are going to have A11 multiplied by Y1, then A12, this A21 multiplied by Y2 and A31 multiplied by Y3. And all of that now, being the first constraint now, is going to be a greater than or equal to constraint. All of that will be greater than or equal to C1. Okay. So that's how it's going to be. So that will be subject to A11, Y1 plus A21, Y2 plus A31, Y3 greater than or equal to C1. Again, the first constraint is a greater than or equal, the first variable, sorry, x1 is greater than or equal to 0. So for a greater than or equal to variable, for a maximization primal, all right? So this is maximization primal, minimization primal, very important to avoid confusion. So if the primal is a maximization problem, then if you have a greater than or equal to constraint, the primal constraint corresponding to that is going to be a greater than or equal to constraint. And of course, it's going to correspond with the C1 in the objective function. So now you have that. So A11, Y1, A2, 1, Y2, A3, 1, Y3 is going to now be greater than or equal to this C1 in the objective function. So now, the second constraint is going to be determined by the second variable. Now, you see, the second variable is actually a free variable. The second variable is a free variable. What does the law say about a free variable? When you have a free variable, the constraint corresponding to it is going to be an equality constraint. Okay. So you're going to have an equality constraint. And how do we get the constraint again? So now, if I can change the marker, okay, let me change it to this. So now we are going to have A2, A12, Y1, A22, Y2, A32, Y3 equal to C2. Okay. Equal to, it is equal to now because the second variable is a free variable. So the constraint corresponding to it is going to be a free constraint. I mean, it's going to be an equality constraint. So we have, okay, we now have A12 Y1 plus A22 Y2 plus A32 Y3 equal to C2 because the second variable is actually a free variable. So the constraint corresponding to it will be an equality constraint. That's coming from here. Free variable, equality constraint. Greater than or equal to variable, maximization primal, that's greater than or equal to constraint. So that's taken care of. Now, we have settled the constraints, right? So the next thing is we have three variables. We have basically variables y1, y2, and y3 now. So what is going to determine each of these variables is going to be based on the constraints because, three constraints leads to variable. Now, the first constraint, right, is a less than or equal to constraint. So what is y1 going to look like? So if you have a less than or equal to constraint, then y1 is going to be a greater than or equal to 0 constraint. So this is going to be greater than or equal to 0, okay? Settled. Then for second constraint, the second constraint is an equality constraint. So when you have an equality constraint, what happens? Whenever you have an equality constraint, the variable corresponding to it is going to be free. So, I mean, we've seen that this y1 now is, because it's less than or equal to here, it's going to be greater than or equal to. Now this one is going to be free. It's going to be a real number. So we can come to y2 and say this is actually real, meaning that it can be positive or negative. Then for the third variable, what does the third constraint say? The third constraint is a greater than or equal to constraint. So for a greater than or equal to constraint, it means that the variable is automatically going to be a less than or equal to constraint. So it means that y3, so greater than or equal to constraint, then y3 is going to be a less than or equal to variable. So we just come here and say this is a less than or equal to variable. Yeah, I mean, I think it can be a lot, but I mean, if you go over it, it's actually logical, especially if you master the transitions. Constraints lead to variables, variables lead to constraints, basically, and just master the table and all of that will be summarized. So this is how far we've come here. Pay attention, just go over it until you perfectly understand it. In the next video, I'll be taking a practical example to drive the points home, and then afterwards, I'll make another video for the Python code. So if you have not subscribed to this channel, you can see already that there's a lot you are going to learn here. There's a lot already available, and there's lots more coming. So please subscribe to this channel so you can always have access, and of course, hit the notification bell so you can always get alerted each time a new video is released. And then don't forget to comment. Let me know if you wanted to teach a topic or solve a problem. And then like and share so that more and more people can have access to this great learning. Till I come your way again, keep optimizing. Bye.